Okay, so here's your starter. We got electric potential of 12 volts. It's applied to an electric motor. The current through the motor is measured to be 3 amps. A, what is the resistance of the motor? And B, what is the power delivered to the motor? Okay, so, see, given. Now, we know that the voltage is 12 volts. And from what we did last time, you can use the letter V or you can use the cursive E, but I'm just going to use V. The current through the motor is measured to be I equals 3 amps. And what are we trying to find? What is the resistance of the motor? So for part A, we're trying to find R. And then for B, we're trying to find what is the power, capital P. So to solve this, for A, well, what's the relationship between voltage and current and resistance? Well, resistance equals voltage divided by current. That's Ohm's law. So we've got 12 volts divided by 3 amps. What's 12 divided by 3? That's 4. And what's a volt per amp? It's an ohm. And then for part B, what's our Watt's law? Power equals current times voltage, PIV. Or if you use the cursive E, it's pi, which is kind of cool. And the current is 3 amps times 12 volts. And 3 times 12 is 36. And that is, an amp times a volt is a watt. Now one of the things, so here's your answer. Now one of the things that I really want you to know is how these units work. An ohm is a volt per amp. But how do you get an amps times volts? How does that give you watts? Well, an amp, remember, is a coulomb of charge going by every second. So it's a coulomb per second. And what is a volt? A volt is a joule per coulomb. So if you have 3 coulombs per second going by, and each coulomb delivers 12 joules of energy, you're going to deliver 36 joules of energy every second. So that's how that works. Okay? Any questions? All right. So the main thing is you need to know the relationship between power, current, and voltage, and you need to understand the relationship between resistance, voltage, and current. Ohm's law and Watt's law. That is all.